Hi, we are Team 15, and our project is the Peach Data Engine for HaMpton Pregnancy. The main client of this project is Professor Asma Khalil of St. George's Hospital and HaMpton Medical, in collaboration with Professor Neil Sabir of Great Ormond Street Hospital. Our team consists of Riara Mandana, Max Burfield, and Selena Lee. In the past 2 years, Asma Khalil has developed HaMpton Medical, a mobile application which allows pregnant patients to record daily blood pressure readings from the comfort of their own home. Blood pressure is a crucial health metric for pregnant patients, as it can be used to diagnose the occurrences of very severe abnormalities, such as preeclampsia, a leading cause of fatalities and stillbirths. Over the past couple years, HaMpton Medical has generated a lot of valuable blood pressure data. In the hands of capable data scientists, this has the potential to train new statistical learning methods to develop a new predictive model for early detection of preeclampsia. Machine learning has been successfully applied to medical research to improve the diagnosis and prevention of complex diseases in the field of pathology and oncology before. Professor Khalil wants to introduce the same solution to maternal-fetal medicine. Currently, Asma's data sits in a password-protected Excel file stored locally where every patient has a table of their own readings. While this format is serviceable from a clinician's point of view, it makes running macro analysis on the data all but impossible, due to the difficulty of getting all the patient's data at once, as well as the lack of standardization across patients. If multiple data scientists want to access the data, they each have to get sent the same Excel file with the same password manually. Since the file can only be updated locally, each copy quickly goes out of date. If a data scientist were to leave the project, it would be impossible to revoke them access to the data that they already have. This mess is no fault of the clinicians who recorded the data. They collected the data in a way that makes sense for them. In fact, clinicians across the world are discovering similar problems. As doctors deal with patients every day, they think of fascinating ways that AI can garner incredible insights from their data, only to be met with practical barriers when it comes to implementing those algorithms. What's needed is a centralized place for clinicians to securely upload their data. It needs to be able to handle millions of data points, easily connect with machine learning solutions, and be in a format that data scientists can securely, reliably, and efficiently get access to the data they need to create great progress in the healthcare field. This project, done in collaboration with the Platform for Enhanced Analytics and Computational Healthcare Group, is called the Peach Data Engine. For this project, we built the Peach Data Engine API for developers and data scientists. For Asma Khalil, we built a front-end application of the API, which allows for her team to visualize the data quickly and efficiently. We also built out a machine learning-ready Spark cluster aspect of the data engine to be expanded on in the future. The front-end application uses the Python framework Django to generate web applications. Django controls login, uploading of files, and submitting data queries. To generate the data visualizations, the JavaScript library chart.js is used to produce interactive data graphics. The Peach API is written in Express, an HTTP framework for Node.js. To store and query data, the distributed NoSQL database known as Azure Cosmos DB is used. The API uses the Azure Cosmos JavaScript SDK to make effective use of this database in querying, uploading, and updating data. The machine learning engine is an Apache Spark program which queries the Peach API using HTTP requests. The Spark program can be run on a cluster of computers using software like Kubernetes and Docker for cluster management. The Peach API has routes for retrieving, uploading, and deleting data for patients and readings. Data is uploaded and returned in JSON format. Each user receives a token, which ties them to their organization. Organizations can store data independently of one another without interfering with any other data stored in the system. The tokens are used to authenticate each request made to the API to ensure security of the data. The HaMpton front-end application makes those API calls to retrieve and upload data to the Peach Data Engine. The application is split into two sections, uploading and querying. The query system allows for ease of querying patient data based on several parameters. Data can be retrieved by entering the type of graph, relative time range, and patient parameters, like if the patient has high blood pressure. Here, we are running a query on the last 10 readings of patients that drank during their pregnancy to see if that has an effect on their blood pressure. Looking at the visualization, we can see that there is no significant difference between patients that drank and did not drink during their pregnancy. Looking closer, we see that only one patient in the dataset did drink, and that this parameter is not a very significant predictor. Users can also download the data and view it in table form. On the upload half of the application, it is clear and easy to upload data in the HaMpton format, which is automatically cleaned and imported into the Peach data engine in the Peach format. Overall, the HaMpton front-end application makes efficient use of the Peach data engine API and is easy and intuitive to use for data scientists and clinicians alike. What we have created here is a solution to the problem of big data in a medical context. By allowing data scientists, clinicians, and researchers to meet on a centralized and standardized data engine, we are unlocking the potential of medical data in the 21st century. We have implemented a secure, token-based authentication for data protection and security. Data scientists can now access meaningful data in an efficient way thanks to the standardized API. Clinicians can easily upload data using the same API thanks to our data cleaner. The data engine has helped this data go from a messy Excel workbook to a machine learning-ready distributed database. Asma has been dreaming of an application that can garner the insights she wants to see from her data, and thanks to the Peach data engine, that is now possible. We made an interactive data visualization web application using the Peach API. With a data engine in place, data scientists, doctors, and clinicians face no technical barriers to running advanced algorithms on their data. What can be done with patient medical data is now only limited by the doctor's imaginations.